And we are solving question number 4 from the prerequisite series. Question number 4 asks you to state the domain and the range of each of the function which is given to you. In the very simplest terminology, domain is all the x values, possible x values, and range is all the y values corresponding to these x values that we have chosen for the domain. For example, if you'll see part A has given us a semicircle on a graphical representation. Now, if I see, if I want to mention the domain of this function, what am I going to see? I'm going to look at the x values here. This is my x-axis. So on the x-axis, the x values that this semicircle is covering is from +2 to -2. That means what x values do I have? I have the x's which is -2 or greater than -2, or it is +2 or less than +2 on the left hand side. So domain is all the x values that lies between -2 and +2. Then we have range. Range is the y values corresponding to these x values. When I say corresponding to these x values, all I mean is I am not going to look at the whole y axis. I am only going to look at the y values for this semicircle, the one that we have discussed the one that we have considered to decide the values of x. So on this semicircle, the y values are from 0 to 2. That means my y is greater than 0, of course, but is less than +2. This is the range. Now, how to represent this domain and range? Is this the way? I mean, this is one of the possible ways, but a better way of writing domain and range is actually set builder form. How do we write set builder form? Set builder form we write starting with curly braces or curly brackets. So curly braces or curly brackets, then we are going to write what are we writing. So if we are writing domain, we are going to write x. If we are writing range, we are going to write y. So in case of domain x, what is x? X belongs to all the real numbers. This means belongs to. This means real numbers, all the real numbers. But it contains all the real numbers. When I say real numbers, I mean all the decimals and the fraction that lies between. Apart from this thing, there is a restriction on x. What is that restriction? That x is greater than -2 and less than +2. Similarly for y is a range and y belongs to all the real numbers. All real numbers means, again, it includes all the fractions and the decimal points in between. And again, this line means such that where y belongs to all real numbers such that 0 is less than equals to y less than equals to 2. So this is my domain set. Now this is domain set and this is my range set. Similarly for part B, there is a quadratic function x square minus 6x minus 10. Now, one thing that I should know is the quadratic function. What is the graphical representation of quadratic function? A parabola. Because I have learned how to write domain and range of a graphical representation, I'll try to imagine my function as a graph. So all the quadratic equation, they end up making a graph, making a parabola on the graph. Now, since x square, if there is no number written in front of x square, we just assume it to be 1. And since 1 is a positive number, that means, what is this called? This is called a leading coefficient. Leading coefficient is a number that is being written with x. Leading coefficient. If my leading coefficient is a positive number, I know my parabola is going to be upwards, an upwards opening parabola. If it is opening upwards, I know what is going to be the minimum point on this parabola. The minimum point of this parabola is going to be this, the vertex of the parabola. The vertex is going to be the minima of the parabola. Minima or the minimum point of the parabola. That means if I am going to write the domain is going to be all the real numbers on the x. We do not have any restriction here because, whenever we are given any equation, the restrictions are always the denominator. Since in this function we do not have any denominator, that means there is no restriction on x. That means for part B, the domain if I am trying to write it in set builder form, should look something like this: x, where x belongs to all real numbers. No restriction. I'll close the set builder form. I'll close the set. Now, in order to find the y values, because is there any restriction on y values? Because my parabola can look like this. My parabola can look like this also. My parabola can look like this also. So what is this y value? Is this, do we have parabola on the positive y's, on the negative y's, or do we have parabola at 0, right? So I want to determine the value of y which is permissible for this equation here. For that, what will I do? I just recognize that if it is an upwards opening parabola, the minimum point is going to be vertex. Let's try to find the vertex. The given function is fx is equals to x squared minus 6x minus 10. The formula for the vertex for a parabola is negative b divided by 2a. In the standard equation, the leading coefficient, this equation can be written as ax squared plus bx plus c. So leading coefficient is a, I have 1, and b is the coefficient of x, which is negative 6. So minus sign from the formula, and the value of b is negative 6 divided by 2. What is a leading coefficient? If there is nothing, we assume it to be 1. So 2 times 1. Here I have negative negative becomes positive. I have 6 divided by 2, which is 3. Now, corresponding to this value of x, I require to find the value of y. That means, what am I going to do? I'm going to take up this value of x, replace x here. That means I am going to find f of 3. That will be 3 squared minus 6 times 3 minus 10. That is going to be 9. 3 squared is 9 minus 6 times 3 is 18 minus 10. Now 9, negative and negative is positive. So negative 18 and negative 10 is negative 28. Negative 28. Now 9 is positive, 28 is negative, so we are going to subtract the two numbers, but since 28 is a bigger number, the answer will be negative. So 9 take away 28 is 19. That means my y value is 19. Oh, that means my vertex is actually 3 and 19. My vertex is 19. That means okay, for x, this is how roughly the parabola is going to look like, 319 here. That means I do not have any restriction on x, but for the range, what restriction do I have? For the range, I have y such that y belongs to real numbers, but the restriction is y has to be strictly greater than equals to negative 19. I am not including any y values below 19. Y values has to be all above 19, not less than 19. That is the only restriction I have on the y values, and so for the range as well. Now let's jump to question number C. Part C says y is equals to 1 over x. Now I told you the only restriction that we have on the function is the denominator. So to find the restriction, what do? We put our denominators is equals to 0, and we try to find the value of whatever variable we have in the denominator. So denominator equals to 0, denominator is x equals to 0. That means this is my restriction. That means my function is not defined when x will become 0. Also, we know that 1 over 0 is undefined, right? So that is the only restriction that we have. Now, one thing to see here is if y is equals to 1 over x, I can also write it as x is equals to 1 over y by cross multiplying it. That means the restriction of the variables not equals to 0 exist for both x as well as y. That means everything boils down to this. The domain is equals to x, where x belongs to all real numbers, but x is not equals to 0, such that x is not equals to 0. Similarly, range, where range is y belongs to all real numbers, such that y is not 0. So this is the domain and range for part C. Moving on, part D, y is equals to 3 sine x. For any trigonometric ratios, how are we going to start? Because we know the restriction on the trigonometric ratios. If you recall the graph of sine x, you will remember that sine x fluctuates between -1 and +1. So the y values of sine x, they never exceed -1 and +1. Here also, since this is a function and we do not have any denominator, so the domain is going to be all the real numbers. There is no restriction on the domain. So x, where x belongs to all real numbers. Let's see if there is a restriction on y. Now, since I know that, the trigonometric ratio sin x fluctuates between -1 to +1. But in the question, I need 3 sin x. That means 3 is being multiplied by sin x. That means what am I going to do? I'm going to multiply all the sides of the inequalities by 3. So I'm multiplying all sides of inequality by 3. That means this becomes 3 times -1 less than equals to 3 times sin x less than equals to 3 times 1. So 3 times -1 is -3 less than equals to 3 sine x less than equals to 3. Now 3 sine x is nothing but y. That means I have -3 less than equals to y less than equals to 3. That means y values, they fall under range. So range is y, where y is all the real numbers such that -3 less than equals to y less than equals to 3. This is going to be my range, domain and range for the part D. Now last part for the question number 4, part E. G of x is equals to 10 raised to the power x. D part says g of x is equals to 10 raised to the power x. First of all, this is an exponential function. Do we have any restriction on x? We do not have any restriction on x. So domain is of course going to be all real numbers. No restriction on x. X can be positive number, can be negative number, can be a fraction, can be a decimal, can be rational or irrational number. We do not care. So no restriction on x. But do we have any restriction on y? Let's see. Here if you'll see, g of x is nothing but your y. Now if I write y equals to 10 raised to the power x, I ask you one question. Do you think, is there any possible value of x which can make this computation negative? In my knowledge, there is no such value, but I challenge you. You try to find any value which is possible. Try to replace x with any possible value and see if you ever will get 10 raised to the power that number as a negative output, as a negative answer. So this never happens. For exponential functions, it never happens. Even when you'll see the graph of the exponential function, they include only the positive values because it is never negative. The least number, even if you put x is equals to 0, we know that any number raised to the power 0 is 1. So we are not even sure that this number will ever be 0. This cannot be 0, although this can be decimals between 0 and 1. So what am I going to say? That y can never be 0, but y can be greater than 0. Greater than 0 means it can have decimal that looks like 0.0009 or 0.0001. It can have decimal that looks like this, but it is not going to be exactly equals to 0 ever. That is just a property of exponential functions. But of course, I encourage you all to replace x with real numbers and try to find this fact on your own. So here the range is going to be y such that y belongs to all real numbers and the restriction is y is strictly greater than 0, not even equals to 0, strictly greater than 0. Yes, this is the end of question number 4. We are done with finding and recalling how to find the domain and the range of different kind of functions, whether it is a graphical representation, a quadratic equation, a fraction, a trigonometric ratio, or an exponential function. I'll see you all in the next video. If there is any questions or queries, please do not shy away from putting it in the comment section. Bye bye.